This video is about transformers. Question 1. What does a transformer do? Draw a symbol of a transformer. A transformer is a device which decreases or increases the voltage of alternating currents. Okay, so take a look at this image. The box in the middle is a step-down transformer. There is an AC power source to the left of the transformer. And notice that the number of loops on the right side are less in number than the number of loops on the left side. Because of Lenz's law, there is a changing or varying magnetic field B inside the transformer since the current changes direction. Okay, so you see this image, we have a power source on the left side for alternating current. So this alternating current comes into this transformer. And since the current continues to alternate, the magnetic field lines continue to change its direction. And since we have a change in magnetic field, we're going to get an EMF from Faraday's law, and we're also going to get Lenz's law to produce an alternating current out. So you see we have AC in, alternating current in, AC out, alternating current out, primary loops on the left side and secondary loops on the right side. And this B here with the arrows is the changing magnetic field. So here's another image. The box in the middle is a step-up transformer. There is an AC power source to the left of the transformer. Notice that the number of loops on the right side are greater in number than the number of loops on the left side. Because of Lenz's law, there's a magnetic field B inside the transformer, which changes direction since the current changes direction. Question 2. How is current induced in a transformer? In other words, how does current transfer from the primary coil to the secondary coil? So, two wires are looping around an iron core, which is the transformer. An alternating current is generated from a power plant which travels from one wire, the primary wire. The primary loops from the primary wire contain an alternating current which induces a change in magnetic field in the iron core, which continuously changes its direction according to the alternating current. So recall Lenz's law from the previous video. Another alternating current is then induced in the secondary coils, and finally the alternating current in the secondary coils travels to the secondary wire. Question 3. Is a transformer used for alternating current, direct current, or both? A transformer can change the voltage of alternating current only. Question 4. Circle the correct choices in italic fonts. The power in a step-up transformer stays the same. The number of secondary loops in a step-up transformer is more than the number of primary loops. A step-up transformer decreases the current while increasing the voltage through a wire. The frequency of the secondary coil in a step-up transformer is equal to the frequency of the primary coil. Question 5. Draw a step-up transformer. Draw arrows to show the direction of the current. So this is a step-up transformer. Question 6. Circle the correct choices in italic font. The power in a step-down transformer stays the same. The number of secondary loops in a step-down transformer is less than the number of primary loops. A step-down transformer increases the current while decreasing the voltage through a wire. The frequency of the secondary coil in a step-down transformer is equal to the frequency of the primary coil. Question 7. Draw a step-down transformer. Draw arrows to show the direction of the current. So you see in a step-down transformer, the number of primary loops is greater than the number of secondary loops. Question 8. State the equation for a transformer which relates the primary voltage to the secondary voltage, the primary current to the secondary current, and the primary number of loops to the secondary number of loops. So here we have voltage primary divided by voltage secondary equals number of primary loops divided by number of secondary loops equals current secondary divided by current primary. Question 9. The voltage from a step-up transformer to a step-down transformer decreases from 120 volts to 60 volts. The number of loops in the primary transformer is 1000. Calculate the number of loops in the secondary transformer. Well, they gave us E sub P and E sub S, and they gave us N sub P. So now we just solve for N sub S. Question 10. The batteries in a portable CD player are recharged by a unit that plugs into a wall socket. Inside the unit is a step-down transformer with a turns ratio of 13:1. The wall socket provides 120 volts. What voltage does the secondary coil of the transformer provide? So we have this equation again, and we just solve for E sub S. E being EMF, electromotive force, which has units of voltage. Question 11. In some parts of the country, insect zappers with their blue lights are a familiar sight in a summer evening. These devices use a high voltage to electrocute insects. One such device has a voltage of 4150 volts, which is obtained from a standard 120 volt outlet through a transformer. If the primary coil has 17 turns, how many turns are in the secondary coil? So we're solving for N sub S. Question 12. Electric doorbells found in many homes require 10 volts to operate. To obtain this voltage from a standard 120 volt outlet, a transformer is used. Is a step up or step down transformer required, and what is the turns ratio? Well, this is a step down transformer since the secondary voltage is less than the primary voltage. And the turns ratio is N sub P divided by N sub S. Question 13. A step-down transformer is used with an electric train to reduce the voltage from the wall socket to a value needed to operate the train. When the train is running, the current in the secondary coil is 3.4 amps. What is the current in the primary coil? So we're going to use the equation again. Question 14. The input to the primary coil of a transformer is 120 volts, while the current in the secondary coil is 0.1 amps. When 60 watts of power is being delivered to the circuit attached to the secondary coil, what is the voltage across the secondary coil? Is a transformer a step down or a step up or step down unit, and what is the turns ratio? So once again, we use this equation again. We're also going to use P equals IV to solve for voltage, or E sub S. Question 15. The secondary coil of a transformer provides the voltage that operates an electrostatic air filter. The turns ratio of the transformer is 1 to 43. The primary coil is plugged into a standard 120 volt outlet. The current in the secondary coil is 1.5 milliamps. Find the power consumed by the air filter. So we're also going to use P equals IV at the end. Question 16. A generating station is producing 1.2 megawatts times 10 to the 6 of power that is to be sent to a small town located 7 kilometers away. Each of the two wires that comprise the transmission line has a resistance per unit length of 0.05 ohms per kilometer. Part A, find the power loss in heating the wires if the power is transmitted at 1200 volts. So, first step, we have to convert ohms per kilometers to ohms. We know P equals IV, so we could solve for I. And we know P equals IV equals I squared R. Part B, if a ratio of 1 to 100 step-up transformer is used to raise the voltage before the power is transmitted, how much power is now lost in heating the wires? So, once again, we're going to use P equals IV. Question 17. Describe the following effects in a non-ideal transformer. Flux leakage means all of the magnetic field lines from the primary loops do not pass through the secondary loops. And in an ideal transformer, the magnetic field lines will loop around both the primary loops and secondary loops. Part B. Joule heating. Resistance of the coils and the wires leads to the wire and transformer increasing its temperature. We can overcome this by minimizing the current and maximizing the voltage. Eddy currents. Unwanted currents induced in the iron core of the transformer. We can minimize eddy currents by laminating the iron core. Finally, magnetic hysteresis. The iron core becomes magnetized, which makes it more difficult for the induced magnetic fields to change direction. Because of this, energy is lost and the iron core is heated up. There is no solution for this. Question 18. Where are you most likely to find a step-up transformer and why? It's outside a power plant because high voltage and low current in the wire will minimize energy loss. Question 19. Where are you most likely to find a step-down transformer? Why? You are most likely to find a step-down transformer near and outside a commercial, industrial, or residential district because a much lower voltage and larger current in the wire is needed. The energy losses are already minimized since they have already traveled a great distance from the power plant with the high voltage and low currents. Question 20. Why is the voltage through a wire from the power plant to a neighborhood so high? High voltage and low current is needed to minimize energy loss. So if we have I squared R, If we square I, if that number is less than 1, that number is very small.